Hello, everybody, and welcome to episode 2 of Gen Z Finance. This show is meant to, make investing and financial concepts a little bit more digestible, especially to a younger audience, because I've noticed that a lot of content out there is not geared toward, younger audiences. So hopefully this is informative to you and helps you out a lot, because I wish that, I had had some of these resources when I was a little bit younger. Um, so this video is part two of a two-part series about the time value of money, which is kind of like the bedrock of all financial modeling concepts, and something that you'll learn in Foundations of Finance or a similar course depending on your university. Um, and I think that even if you aren't a finance major or even if you aren't familiar with these concepts, I think that they're really valuable to learn. And I think they can help you understand a lot about financial modeling and how to think about money both in the future and in terms of present value. So the first episode, which I highly recommend you go and watch, is all about compounding. So compound interest, how much money invested today will be worth in the future. This video is going to be the reverse of that, right? So we're going to talk about discounting, or in other words, how much money in the future is worth in today's dollars, right? So with that, we're going to talk a little bit about what we're going to talk about in this video. So we're going to first define what it is, what discounting is. Then we're going to walk through a little bit of the mechanics of how discounted cash flow analysis works. And then we're going to walk through a real simple example with a lemonade stand. So this will just kind of be similar to a tutoring session, and hopefully it's really informative to you and more digestible than other videos out there. So, discounting is just this idea that if you have an interest rate, right, then, then if you invested money, right, it would be worth more in the future. So if you take that as a premise, right, then the reverse must also be true, right? Money in the future must be worth less than money today, right? So the general premise is that a dollar tomorrow is worth less than a dollar today. I would rather consume today than tomorrow, right? Especially if I could earn interest on it, right? So in this example, and in all the examples in this video, we're going to use the interest rate of 2%. 2% is a good interest rate to use for financial modeling because it's pretty close to the 10-year Treasury rate. The 10-year U.S. government Treasury rate is a good Treasury rate because it's the safest asset that there is, and so it provides a good benchmark to start with. Although you can change it around and you can use really any interest rate you want for financial modeling. But for this video, we're going to use 2%. And so, the best way to visualize, the concept of discounting or discounting future cash flows back to the present value is by using just, two really quick examples just to understand the mechanics about how the math works for a discounted cash flow analysis, right? So we're going to think about $100 today versus $100 next year, right? So right now we're in 2022, next year is 2023, right? So $100 in 2022 is just worth $100. However, $100 in 2023 would be worth less, right? Because you have to discount it back using that 2% interest rate, right? And I'll show you how the math works. So let's write in our little table here. We've got all the years laid out. Let's use that $100 number. So we've got $100 to be received in 2023, and we want to find out what's the present value, or PV, of that amount of money in 2022 dollars, right? So the way we're going to set up this equation is we're going to set this cell equal to that $100 divided by parentheses 1 plus our interest rate, which is 2%, right? And hit enter. So now we see that $100 received in 2023 is actually $98.04 in terms of $2022, right? So it's worth less today than it is tomorrow, right? And then, we can use another example, right? So let's erase these formulas. What would that same $100 be worth if we received it in 2024, right? If we received it in 2024, the way we would set up this formula to find out how much it's worth in 2022 would be by setting this cell equal to that $100 received in 2024 divided by, divided by 1 plus our interest rate of 2% raised to the second. And the reason we raise it to the second is now we're discounting by 2 years. So instead of discounting by 1.02, now we're discounting by 1.02 times 1.02, or 1.02 raised to the second power, right? And as you could probably guess, it's going to be a smaller number, right? Because we have to wait longer to receive that money in the future, and therefore it's less valuable today. So as you can see, now it's $96.12, right? So we've actually lost a little bit more of that value. And this, the similar logic applies if you keep going, right? If that $100 received in 2030, it's going to be worth way less than if it was received this year or next year, right? Because we have to wait longer to get it, right? So that's how the mechanics work, and it's pretty simple math. And now let's walk through a simple example of a lemonade stand, right? The way that this concept of discounting is applied in the real world is by valuing companies, right, or valuing equity in stock, right? So it's a very key principle in financial modeling. So the way that any investment would work, whether you're investing in stock or a company, right now we're going to be thinking about investing in a lemonade stand, is that you have an initial investment profit every year for a given amount of time. Right now we're using a 10-year time horizon. And then we're going to find out how much that initial investment combined with that profit in terms of today's dollars is worth, right? So if the present value of all of those cash flows for each of the 10 years is more than the initial investment, that means it's a good investment, right? However, if it's less, that means it's a bad investment. You would not want to invest in it, of course. Why would you want to make negative money? So let's walk through a couple different scenarios, right? So let's say that it costs you $100 to open your lemonade stand, right? Buy lemons, do your advertising and buy your stand, right? So you've got a negative cash outflow in 2022 of $100, right? Let's also assume that you're going to make $20 per year for all 10 years as profit, right? So let's do $20. And then let's drag this formula bar out for all 10 years, right? Okay, so now we're making $20 in profit, and now our next job is to find out how much the present value of each one of those $20 cash flows in each year is worth in terms of $2022, right? Because you have to match apples to apples, right? You have to match that negative $100 cash outflow with the present value of all of those cash flows, right? Because it wouldn't make sense to value them in terms of their future value in nominal terms, right? We want to know the present value of all of those cash flows, right? To see if they outweigh the initial investment, right? So let's set up our formula again. We're going to set up our formula as follows. So we're going to set this cell. This cell is just equal to the first year profit. There's no discounting in year one, right? Because there hasn't been enough time for there to be any discounting. However, in year two, we are going to start running into discounting. So here, we're going to set this cell equal to the $20 in profit in 2023 divided by 1 plus our interest rate. And here, I'm going to lock in this interest rate. I'm going to anchor it using the money signs. You have to use the money signs because otherwise when I drag the formula bar, it's going to change this value, and we want to lock in that value. We want the denominator of 1.02 to be constant throughout our entire formula. So that's why we're locking it in. Now we're going to raise this to, we want a sliding number, right? Because we're going to copy this formula down all the way. So this one, we want it raised to the first power. In 2024, we want it raised to the second power. In 2025, to the third power, and so forth. So there's many ways you could do this, but the easiest way is to go like this, right? So we're going to set this equal to 2023, so the current year, right, minus our base year, right, 2022. And just like the interest rate, we want to lock in our base year. So everything else in the formula will change as I drag it along, but we want our base year to stay the same, right? And what this will do is it will increase that exponential factor by 1 for each year that it moves down the sliding scale, right? So in 2023, it'll raise it to the power of 1. In 2024, it'll raise it to the power of 2, and so forth. Right? So it's a nice, easy way to set up that, that exponential factor. Right? So now we can see that. And now we're going to drag out our formula bar all the way throughout our timeline to get each year's profit in terms of current 2022 dollars, right? So you can see the farther out you go on the timeline, the longer you have to wait to get that profit, and therefore the more discounting that's happening, right? In 2031, you're discounting by 1.02 times 1.02 times 1.02, and so forth, right? Whereas here you're only, in 2023, you're only discounting by 1.021 time, right? So the more you go out on the timeline, the more you're discounting and the less valuable it is, right? Now, our job is to find out if all of those cash flows in terms of present 2022 dollars outweigh that initial $100 investment. So let's set up our formula for the total present value of the investment. So this is going to equal our initial investment minus, plus the sum of the present value of all of these cash flows. Okay, we're going to close out our parentheses, and we're going to find out that the present value is $83.24, right? So this is a good investment given this interest rate and given these parameters, right? But you can see how that discounting plays into effect in terms of the investment decision, right? If you didn't have any interest rate involved and you didn't have any discounting, right, over those 10 years you would earn $200 in profit, right? So you would actually earn $100 in terms of your investment. But we're thinking in terms of present value, right? We're concerned with the present value of those dollars, and using that 2% interest rate, all of those cash flows are not worth $200, but $183.24. Subtract that $100 investment, and now you're at $83.24, right? And so now we can play around with the parameters of our scenario, right? What if instead of 2% interest, what if we have 20% interest, right? Let's just use it as an example, right? You can see how now our total profit, or our total present value is not $83 anymore. Now it's only 62 cents, because the more you increase that interest rate, the less valuable future cash flows become, right? So instead of, this was worth like 16 bucks before, right? Now it's only worth $3.88 in terms of present value dollars, right? So And if you increase it even more, we can see what happens. Let's see if we increase it to 21%, right? Now, using this assumption, now we're actually earning a total present value that is negative, right? So this investment is no longer a good investment. So you can see that this interest rate and the discounting that happens because of it really impacts the your assessment of this lemonade stand as an investment, right? If you use 2% as an assumption, then you're at you're positive and it's a good investment. However, if you're at 21%, then it's not, right? And we'll talk about more about how this affects investments in later videos. But this is a pretty basic example to wrap your head around it. You can also, this is a very simplified example. You can also have other factors in the discounted cash flow analysis, right? You can have salaries paid to employees. You can have taxes. You can make it endlessly complicated. But this is a pretty good example of how to model a financial situation and an investment, and I think really just sets the ground for understanding financial concepts. And I think if you understand this, you'll understand almost everything else related to finance. So please keep it in mind, and also go check out that other video about compounding, as these two concepts are very related. And stay tuned for future videos. If you really like this video and you thought it was helpful, please subscribe. Please like it, because I think that this channel could fill a niche that is not currently filled in financial videos. And I will see you next time. Thanks for watching.